Hello, let's talk about the task we are going to solve in this course. Here we can see a public dataset on GitHub of the Deutsche Börse, the German marketplace organizer for trading of shares and other securities. There are actually two datasets, the Xetra and the Eurex data. For us as a source we take the Xetra dataset. Xetra stands for Exchange Electronic Trading and is the trading platform of the Deutsche Börse Group. This dataset is derived near time on a minute-by-minute basis from Deutsche Börse's trading system and saved in an AWS S3 bucket available to the public for free. The link to the GitHub repository is in the course material, and as you can see here, you find detailed information about the dataset, the naming convention, and more. Let's see a sample of the dataset to get a first impression. The first column lists the ISIN, the International Securities Identification Number. Each entry of an ISIN shows basic information such as the security type and security ID, and on a per minute basis, the start, max, min, and end price, the traded volumes, and the number of trades. And now let's imagine our company, client, or ourselves want to get a report that is looking like this. Here we see an aggregation of the ISINs on a daily basis, and what we want to know are the opening, closing, minimum and maximum price, the daily traded volume, and the change of the current day's closing price compared to the previous trading day's closing price. And our task now is to create a production-ready Python data job that is extracting the source Xetra dataset from the Xetra S3 bucket since the last run of the job, and saves the report we just saw on the last slide to a target AWS S3 bucket. And as you can see here, a scheduler should be able to run the job on a weekly basis. Let's imagine we are having the calendar week 1. The scheduler should trigger our Python data job, and this should extract the data from the source and save the report to the target bucket. 1 week later, in calendar week 2, the new data in the source that was not processed yet should be extracted again and the report added. In the following week again, after again, and every week just the same. Let's point out some requirements that are important for us as the developers of the Python application. The format of the target files should be Parquet. Parquet is an efficient column-oriented data storage format of the Apache Hadoop ecosystem. It is built to support very efficient compression and encoding schemes. The first date that should be extracted will be given as input. So the first time the job runs, all dates from the input date until the today's date should be extracted and the report should be built. And for all next runs there should be an auto detection of what files already were processed and what not. And the whole Python job should be configurable in this way that if, for example, a column name changes in the source or target report, the code should not be touched, but just a configuration file be edited. And the job should be written that it is production ready. What production ready means, we will learn during the course.